Alright, we're going to go over the word problems for 2.3. They focus on the distribution property and combining like terms. We're going to look at number 1 here in a highlighter. This is the highlighter. A company ordering 350 t-shirts. The company is ordering 350 t-shirts to sell at a fundraiser. The company wants to order the same number of large t-shirts as medium-sized t-shirts, but only half as many small t-shirts. How many of each size should they order? Well, we're going to go ahead and underline our important information, or highlight. We got 350 t-shirts with the same number of large and medium, but only half of the small t-shirts. And we want to know how many of each size should we order. So we know right off the bat that when we set up our equation, it's going to equal 350 because of this right here. And we know that our total, we're going to be adding our large, medium, and small together. So we need to set up a variable to solve this. And we're going to use T for t-shirts. Alright, so if this large and mediums have the same size, or the same number of large and medium, we can set both of our large and medium equal to the same value. And for the small t-shirts, we're only ordering half as many, so small is going to be 1/2 T. So when we set this up, it's going to look like T plus T. They kind of look the same, just make sure you curve your T, or you can use another variable, like any letter in the alphabet works. I just use T because of t-shirts. Should have used S, but this will work. And 1/2 T. So we can set this up, we can simplify this with the distributive property, or since it's already distributed, another way to look at it would be your variables on the outside. 1 plus 1 plus 1/2 is equal to 350. So we can combine all the like terms in these parentheses. We're going to combine that. 1 plus 1 is 2 plus 1/2. We're going to get 2 and 1/2. But until we solve it, we're probably going to keep it as improper fractions. So we're going to get 5/2 is equal to 350. We want the t by itself, so we're going to get rid of this 5/2. We're going to do the inverse operation. Since it's being multiplied, we're going to divide. And we're going to erase this left side so we've got more room to work. We already know what our variables are. Alright. So 350 divided by 2. We can set 350 over 1 divided by 5/2. And with keep change reciprocal, we know that really this is 350 times 2/5. And we can reduce 350/5. We can simplify that to 70/1 times 2/1, because 5 goes into 350, 70 times. So that looks a lot cleaner. 70 times 2 is 140. So 140 is our variable. T equals 140. But we're not looking for what T was. T is what we were using to solve this. What they're asking is, how many of each size should they order? So we can't stop here. We need to plug it in and figure out how many shirts they need. And also, this is a good way to check your work. So I'm going to erase. We're going to move this up here. There we go. We are going to set it up with our initial equation right here. It's a terrible arrow, but we're going to plug it in there. So we're going to get 140 plus 140 plus 1/2 times 140, and then we're going to combine these terms. So 140 plus 140, 280 plus 1/2 times 140. Half of 140 is 70, so 70 plus 280 is 350. So we've got 350 equals 350. But we can also use our equation right up here to figure out how many of each size they should order. We just worked it all out all the way to figure out, or to plug it in and test our answer. So now that we know that our answer makes sense, we can use this equation to make sure to check how much of each size. So if we remember our first variable, t, which were these guys, this is our large, our medium, and our small. So for large, we have 140 shirts. Medium, we have 140 shorts. And for small, we have 70 shirts. All right, moving on to the next question. The perimeter of a soccer field at a local park is 260 feet. The length of the field is 36 feet more than the width. Find the dimensions of the soccer field. So drawing pictures always help with word problems. So we're going to draw this soccer field, and then we're going to highlight our important information. So our important information is that we have the perimeter. The perimeter is 260 feet, and then the length of the field is 36 feet more than the width, and we need to find the dimensions. So with perimeter, the perimeter is just all the sides added up. So our perimeter is our dimensions. So we know our dimensions added together is 260. So we can set this equal to 260. And we know that perimeter is each side added up together. So with the length, which we'll set this side as the length and this side as the width, we know our length is 36 feet more than the width. So 36 plus our W, which is our width, we're going to set our width equal to W. So we're just going to leave that term there. And then we can set up our equation for the perimeter to figure out the individual dimensions. So when we do that, we've got so perimeter is going to be L plus W plus L plus W, right? So we've got 36 plus W plus W plus 36 plus W. I'll make this a little smaller. Oh, it doesn't work that way. Plus W. And all of that is equal to 260. Can I move that whole part? Oh, let's undo that. There we go. All right. A little sloppy, but this is all of it worked like spread out as it is. But using the distributive property, we can simplify this. We're going to simplify it by taking these two terms and get 36 plus W inside the parentheses times 2, because we have 2 of them. And add that with W in parentheses with the 2 outside, because we have 2 of them. And that is equal to 260. So now we can start solving because we've got our equation set up. First things first is we're going to take care of the parentheses so we can combine like terms. When we do that, we've got 2 times 36, which is 72. 2 times W, distributed to W, is and with his addition sign, is added another 2w. And then for this right side, we've got 2 distributed to w, which is 2w, equal to 260. All right, we need to get our variable by the side now, by itself now, because we need to get it by itself so we can figure out the individual. We need to find the width first so we can find the length, and then we'll have the dimensions. So doing that, we combine our like terms. We've got 4w plus our 72 is equal to 260. We're going to subtract 72 to get the 4w by itself. Minus 72 is 188, and equal to 4w. To get the w by itself, we're going to divide out the 4 because we had to do inverse operations, and inverse the multiplication is division. So get rid of that. Divide by 4. We got w is equal to 47. Yeah, 47. All right, so we got w is equal to 47. So if w is equal to 47 and length is 36 more than width, oh, you're good. Then we are going to add 47 to 36, and that will give us our length, which that comes out to be 83. Yeah, 83. But we need to check our work before we move on, and our perimeter is 260 feet. So if we take our 83 and our 47 and we plug them into the original equation, we should get 260. So need to clear some room. I'm going to make this smaller. Alright. Wrong button. Alright. So we've got our 83, which we're just going to use this equation since we already used the distributive property, times 2 plus 2 times 47. And this should equal 260. So 2 times 83 is 166 plus 2 times 47, which is 94, equal to 260. We add these together. We come up with 260. So 260 equals 260. So we know that our answer is right, and we've also got the dimensions, which you would label to the side. Length equals 83, and width equals 47. That's how you check your work and solve that problem. We're going to move on to the final one. Alright, you have 65 bucks in your savings account, and your brother has 140 bucks in his savings account. You're depositing 15 bucks per week to your account, and your brother is depositing 10 bucks per week in his account. And how many weeks will you and your brother have the same amount of money? Alright, so we're going to start off by highlighting the important information. So you have 65 already in your savings account. I'm going to use a different color. 65 already in your savings account, and your brother has 140 in his savings account. So you're depositing 15 per week, and your brother is depositing 10 per week. And the question asks, in how many weeks you have the same amount of money? So that's our important information from this question. So to set this up, we are going to put our important information for us on the left, so 65, and we're depositing $15 per week, so that's going to be addition, so we're adding that. And since we want to know how many weeks, we don't know how many weeks it takes, so in our parentheses you put how many weeks. If you wanted to see how much money you had at a given point, you could plug in the weeks and figure out how much you would have then, but we don't know how long it would take, so we're going to use a variable. We're going to use W for weeks. W equals weeks. And we're going to set that equal to our brother because we're trying to figure out when we have the same amount of money as him. He has 140, so he starts out with that value, and he is adding $10 per week to his bank account. So what we're going to do is we need to combine like terms. So this 15 is distributed to the W. You got your 15W is equal to 140 plus 10 distributed to the W, which is 10W. Now we got to combine like terms now that we're done with the parentheses. So it's going to be a lot easier to move this 10 to the left side because we want our variable to be positive, because you're not going to have negative weeks unless you got a DeLorean. So we're gonna subtract here because that's the inverse operation of addition. That's going to get rid of this, and we're going to subtract 10 here. The 10W, not just the 10. So subtracting the 10, we're going to get 5W on the left. It's equal to 140, but don't forget the 65 over here. Need to get the variable by itself so we can get rid of that 5. So we're going to do the inverse operation. With the commutative property of addition, we know that the 65 is positive. It's being added even though it's on the left side. So inverse operation is negative, so we're going to cancel that out. And then minus 65 from here, we've got 75. 75 is equal to 5W. So we want the W by itself to figure how many weeks. We're going to divide by 5 because that's the inverse operation of this multiplication that's going on here. Cancel that out. We divide by 5. We've got 15. 15 is equal to W. Now, this one isn't like the other ones where we had to plug it in to solve the answer. This one just gives you straight up the answer. But we're still going to check our work because we do our job right. So I'm going to move this up here, and we're going to check our work. So we're going to plug it in. I'm going to draw a little barrier here so it doesn't get distracting. We got 65 plus 15 times 15 is equal to 140 plus 10 times 15. Alright, so we're going to take care of the parentheses first on both sides. So 15 times 15 is going to be 225. And then don't forget the 65 right here. And then we've got 140 plus 10 times 15 is 150. We're going to combine the terms on both sides to see if it really did take 15 weeks for us to have the same amount in our bank account. Alright, so 140 plus 150 is 290, and 65 plus 225 is 290. So in the process of checking our work, we also figured out how much money we would have in 15 weeks, as well as checking our work to make sure it took 15 weeks to have the same amount of money. And that is all.